You may have noticed it already, but the universe is really huge. At night, all those small lights you see shining in the sky are actually massive objects with planets orbiting them, some even 10 times bigger than our own Earth. But hidden in the emptiness of space, there are also far more dangerous things, powerful enough to destroy you in an instant. Do you remember the movie Don't Look Up and the meteor that destroyed the world? Well, that's nothing compared to what we're about to see. So, I hope you are ready because today we are going to explore the event that will destroy the universe. Supernova and hypernova. In the universe, there are many stars much bigger than our own. Take this one for example, Antares, a white supergiant about 700 times larger than the Sun. And as you can imagine, when a star that massive explodes, the result is spectacular. This is how supernovae are born. Supernovae are among the most powerful events we can observe in the universe. They release as much energy as the Sun will produce during its entire lifetime, but in just a few seconds. In numbers, that is 1 followed by 44 zeros. That's enormous. If planets are orbiting the star that explodes as a supernova, they are simply doomed. A single supernova can completely destroy one or several solar systems. But as terrifying as they are, supernovae also play a crucial role in the universe. During the explosion, the star releases the chemical elements it created during its life. Iron, gold, and many other elements come from these explosions. Supernovae also create nebulae, which are a true work of cosmic art. This is how the Crab Nebula was formed, about 6,300 light years from Earth. This explosion was so powerful that it was seen from our planet. In the year 1054, Chinese astronomers recorded a white light in the sky, visible even during the day, for nearly 2 weeks. So yes, from Earth a supernova can look like the birth of a new star, but actually it means its death. Okay, a supernova is already incredibly powerful, but what happens when you multiply that power by 100? You get hypernova. Remember our number with 44 zeros? Now add 2 more zeros, and you get the energy released by a hypernova. Even if hypernovae are still partly theoretical, we know one thing for sure. When a star explodes as a hypernova, its core collapses in on itself, forming black holes. Everyone knows what a black hole is, even though in reality, no one knows exactly what it is. And contrary to what many people think, black holes are not giant vacuum cleaners, but more like funnels. Simply put, black holes are a region of space where gravity is so strong that even light cannot escape. As impressive as that sounds, a black hole does not pull more attraction than any other object with the same mass. For example, if you replace our sun with a black hole of the same mass, the Earth will keep orbiting it as if nothing has changed. Unlike popular belief, there are many types of black holes. They come in all sizes. Stellar black holes about 2 to 5 times the mass of the Sun, supermassive black holes which are billion times more massive than the Sun and are found at the center of galaxies. You have probably seen galaxies like this. It's the black hole at the center and its rotation that makes everything move. And here we are in our small corner of the galaxy, literally moving around a black hole. The largest confirmed black hole in the observable universe is called Neutron 618, a quasar with an estimated mass of about 66 billion times that of the Sun. But have you ever wondered what happens when you get close to a black hole? You will feel like time is slowing down while everything around you speeds up. It might be the only place when you could witness the end of the universe. But don't worry, your body will stretch and chill apart long before that, so you will be dead much earlier. And yet, black holes are not eternal, they are slowly vanishing. According to Hawking radiation, black holes gradually lose energy in the form of radiation until they eventually disappear. But before that happens, humanity will have been gone for a very long time. There is, however, something even more extreme than supermassive black holes, primordial black holes. We can see them. We don't know exactly how they form. We know almost nothing about them, except that they have existed since the very beginning of the universe. The stars of the extreme. This is a neutron star, and don't be fooled by its size. Even if it looks tiny compared to giants like supermassive black holes, these things are real killers. When a very massive star explodes in a supernova, its outer layers are blown into space, while the core collapses in on itself. It gets crushed into a ball only about 20 kilometers wide, like a giant atomic nucleus made almost entirely of neutrons. That's where the name comes from. On the scale of the universe, neutron stars are incredibly small, but insanely heavy. We are talking about 5 billion tons packed into an object the size of Manhattan. To keep it simple, if you took a piece of a neutron star the size of a teaspoon, it would weigh more than 100 million tons. But that's not all. The conditions around a neutron star are so extreme that scientists need all of modern physics just to understand how they work. Temperature on their surface can reach several million degrees. For comparison, the surface of our sun is only about 5,500 degrees. Okay, but why are these nearly stars so dangerous? First of all, if you get too close, you are instantly crushed by your own weight. Second, some neutron stars have an insane gravitational field and spin incredibly fast, like really fast. They can rotate at a speed of up to 157 million miles per hour. These are called pulsars. They emit powerful radio beams that we can detect from Earth, a bit like a giant cosmic lighthouse. But there is an even more terrifying type, magnetars. These neutron stars have the strongest magnetic field known in the universe. It's so powerful that it could disturb or even damage Earth's magnetic field. According to some researchers, a magnetar could even destroy our ozone layer if it were closer than 10 light years away. In December 2004, one magnetar released a burst of gamma rays and X-rays so intense that it altered the upper layers of Earth's atmosphere and even disturbed our planet's magnetic field. To this day, it remains the most powerful explosion ever detected by satellites. Scientists estimate that about 1 out of every 10 supernovae may create a magnetar. Gamma ray burst. If you thought neutron stars were monstrous, you are not ready for what comes next. Gamma rays are literal death rays. Do you remember how hypernovae happened? Well, that's only the least violent part of the death of a hypermassive star, because very often the star does not just explode, it also releases deadly cosmic radiation. Gamma rays fly across the universe at the speed of light. They move so fast that no one can predict them or even see them coming before they hit. And of course, nothing can stop them. Gamma rays pass through almost everything with a power equal to thousands of suns focused into a single beam. The most dangerous ones are long gamma ray bursts, because they can last for several minutes. They happen when a hypergiant star dies and a black hole forms at its core. But not all hypernovae produce gamma ray bursts, and the most worrying part is that we still don't know why. Whether they are long or short, gamma ray bursts almost always announce the birth of a new black hole in the universe. The real problem is that these bursts could wipe out Earth, just like they have probably already destroyed other life-friendly planets. Some scientists even believe that nearly 90% of galaxies have at some point in their history been devastated by gamma ray bursts. The end of the universe. We have seen so far events that can destroy planets, galaxies, and even hundreds of galaxies. But what about the universe itself? Could it really come to an end? And more importantly, how could that happen? To answer this, scientists have proposed 3 main theories about the end of the universe: the big freeze or heat death. In this scenario, the universe keeps expanding forever while slowly cooling down. Stars burn out, galaxies drift apart, black holes eventually evaporate, and the universe slowly becomes dark, empty, and frozen, reaching temperature close to absolute zero. First imagined by the founder of thermodynamics, this is currently considered the most likely fate of our universe. The Big Rip. On the opposite side, there is the Big Rip, based on the behavior of dark energy. In this scenario, the expansion of the universe becomes so extreme that it tears apart the very structure of reality. Planets, stars, galaxies, atoms, and even space-time itself. Proposed in 1999 by Robert L. Cadwell, this theory suggests that dark energy could become stronger than unknown forces, both gravitational and atomic. The Big Crunch. Unlike the Big Rip, there's also the Big Crunch. In this scenario, the expansion of the universe eventually stops and then reverses. The universe begins to shrink, collapsing in on itself until everything is crushed into a single point similar to a Big Bang in reverse. Vacuum decay, the ultimate scenario. This will be the most radical end of the universe. Nothing will remain, absolutely nothing. Even the fundamental laws we know, like gravity or the conservation of mass, will be completely destroyed. It will be a true reboot of the universe. The possible cause, the Higgs boson, the particle that gives mass to everything. According to a theory discussed by Stephen Hawking, our universe might not be fully stable, but metastable. Every particle has different energy levels, with the lowest one called the ground state. When a particle is in this state, its energy is minimal. It's known as a true vacuum state. But a particle can also exist in a false vacuum state, a state that looks stable, but is actually fragile. This is what scientists feel could be the case for the Higgs boson. That it is not in this true vacuum state, but in a metastable state. If due to some disturbance, the Higgs boson then shifted to its lowest energy state, it will create a bubble of true vacuum. And this could happen anywhere, inside an atom at the edge of the universe, or even triggered by something as small as a butterfly wing. This bubble will then expand at the speed of light, destroying everything in its path. The structure of matter itself will change, and life as we know it will no longer exist under today's laws of physics. The funny part is that all these theories are double-edged. Either they are wrong and the universe is truly stable, expanding forever, or they are correct and the destruction of the universe may have already begun. And the worst part is that we will never see it coming.